So we continue further with the equation of line. So what we are having is equation of a line. Now, so up till now we have studied that first thing is slope is m, which is nothing but tan theta, or is equals to y2 minus y1 upon x2 minus x1. Right? And we also know that if I want to know that whether a point is lying on a line or not, I just need to place the value of x and y of that particular point in the equation. If the LHS is equal to RHS, then yeah, it is lying on the line. If not, then it is not lying on the line. Now we see another concept, and that is intercepts. So if this is my x-axis and this is the y-axis, suppose a line is cutting this like this. This is the origin. In that case, this particular distance, okay, this length of this point to this point over here is called as the y-intercept. And this point over here, from here to here, this distance is called as x-intercept. So you can see that the point at which the line cuts the x-axis, okay, the point at which the line cuts the x-axis is nothing but the x-intercept. Like for example, if it is cutting over here at 10, automatically my x-intercept will be 10. If it is cutting here at 5, my x-intercept will be 5. Because it starts from 0, so 1, 2, 3, 4 is anyway marked. So wherever it cuts over here, suppose it's cutting at 4.5, then my x-intercept is 4.5. Similarly, the point at which the line cuts the y-axis is called as the y-intercept. So if I am having this particular markings over here, the marking, suppose your marking is that this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and suppose this point over here is, let's say, 6.5, then my y-intercept will be 6.5. Understood? So the point at which the point on the x-axis at which the line intersects the x-axis, or the point on the x-axis which is on which the line is intersecting, okay, or it is cutting, okay, the line meets the x-axis, is called as the x-intercept, and when it meets the y-axis is called as the y-intercept. The x-intercept is not denoted by any kind of a value, or it is not given by any kind of alphabet, but the y-intercept is denoted by the letter C. Okay, so we have over here y-intercept is denoted by C. Okay, slope is M and y is C. Now let's see what is an equation of the line. So the equation of the line has got the general formula as y is equals to mx plus c. This is the general formula of the equation of a line. The line will always be represented by the equation of the line will be y is equals to mx plus c, where m is slope and c is y-intercept. Okay, so in y is equal to mx plus c, here, yeah, this is the same x as our normal x, so this is x. Y is equal to mx plus c, m is the slope and c is the y-intercept. So we see that when we want to frame the equation or when we want to form the equation of a line, you will be given certain kind of information. And based on the information what you have got, you are going to form the equation of the line. So the first kind of information which could be available and makes the equation of a line, making the equation line simple, is the first method is slope intercept method. Okay, the first is slope intercept method. It is that method in which what is given, so given thing over here is the slope, that is m, and next is y-intercept, which is nothing but c. Accordingly, what you need to do is just use in y is equals to mx plus c. Let's take an example over here. Example, let's take the slope is equals to minus 3 upon 4, and let's take the c to be 5. Then the equation will be y is equals to minus 3 upon 4x plus 5. You can always take the LCM and you can take 4y is equals to minus 3x plus 20, because 4 multiplies over to 20 and 4 comes here. So accordingly, you can have this as the equation, or you can have 3x plus 4y is equals to 20 as the required equation. Got it? This is how you are going to get the equation. So if you are given the slope and the y-intercept, then you are just placing the value of m and c in the equation and getting the required equation of the line. Even if you keep it over here, it's okay, but normally you don't want it in fractions. That is the reason you are going to put it in this formula format. Okay, so this gives you the first method of finding out the slope, or finding out the equation of the line, and that is called as the slope intercept method, wherein you are given the slope of the line, that is m is given to you, maybe in some other way, either they will be giving you 2 points and do it, but anyway, you are getting, you know the slope and you know the y-intercept of that particular line. Maybe they are given you a thing like that, they are given a line, they are given the angle theta, and you know that it is cutting the y-axis at a particular point, so theta will give you the slope, so tan theta, and the y-intercept is known to you, so accordingly you can make the equation like this. That is the first method. We see now the next method, and that is, so see the next method. Second method is point slope method. So in this case, the given will be point x comma y, and second will be the slope, that is m. So if I know the slope of a line, and I know one of the point through which that point through which that line is passing through, right? So if I know that the line is passing through a point which is x comma y, or we'll take it as x1 y1, and the slope is m, so we'll have the formula as y minus y1 is equals to mx minus x1. The formula which we'll be using in case of this kind of a method will be y minus y1 is equals to mx minus x1. So this is called as the point slope method. Let's take an example over here. We take the point P as 3, 2, and the slope is equals to let's say minus 2. Okay. Then what will be the equation? The equation will be y minus 2, because this is x1 and this is y1, is equals to minus 2 bracket x minus 3. So this gives me y minus 2 is equals to minus 2x plus 6. So we get 2x plus y is equals to 8. So this is the required equation of the line. Easy, right? So the next method was point-slope method. So point-slope method, what is required is a point and the slope, right? If you know the slope, you know the point, you can use this method. The third method is two-point method. So next one is two-point method. In the two-point method, what will be given will be P, which will be x1, y1, and Q, which will be x2, y2. You just know the 2 points which are present on that line. Okay. So if a line is known to me, I want to find out the slope I want to find out the equation of the line. Just के 2 points, okay, which is passing through 2 points A and B, or P and Q in this case. The formula will be, it's a very simple formula because exactly it is determined from here. So here it is y minus y1, that remains the same. What is M? Slope. M is the slope. What is the formula of slope? y2 minus y1 upon x2 minus x1. That's it. I'm just replacing that. It is y2 minus y1 upon x2 minus x1 into bracket x minus x1, because that is exactly what was here. So here, भले 2-point method में बोल रहे हैं, but you can always find out the slope separately and use this method. It's one and the same. But yeah, it is called as a method, which is a 2-point method, wherein you will be having it in this particular form. So this and this actually not a difference, but anyway, you can consider it to be different. So suppose we have got a point P, which is 3, 2, and we have got point Q, which is given as let's take it as -2, -3. Okay, let's take it something different. And if this particular 2 points are there, and I want to find out the equation of the line, so what will be the equation of the line? It will be, this will be x1, this will be y1, this will be x2, this will be y2. So we will be at y minus y1 is 2 is equals to y2 minus y1, that is -3 minus 2 upon -2 minus 3, okay, -2 minus 3, bracket x minus 3, right, because x1. So this is nothing but -5 upon -5 is 1, so it is y minus 2 is equals to 1 x minus 3, so it is, we can take it this way, so y is equals to, we can take this as x minus 3 plus 2 is -1. So that's the equation, y is equals to x minus 1, or you can write it also as x minus y is equals to 1. Why put it this side? We only take it as this side, so x minus y is equals to 1, same thing. Okay, so this was how you are going to get the third formula or the third method of writing the equation of line. So finding out the equation of line. So first one was slope-intercept method, so which is where we know that y is equal to mx plus c is the main part, m is the slope, and c is y-intercept. If I know the slope, if I know the y-intercept, I just have to substitute the values in that particular formula and it gives me the answer directly. So that was this method, which is slope-intercept method. The next is point-slope method, wherein you are given the slope of a line and you are given the point through which that line is passing. In that case, the point will be x1, y1. You get the value as y minus y1 is equals to mx minus x1. So you can see in each and every case, we are retaining the variable x and y for the equation. In the equation, you are never going to put any values for x and y unless and until you want to find out that whether a point is lying on that line or not. Otherwise, x and y will be a part and parcel of each and every equation. Unless until, yes, if it is line parallel to x-axis, then automatically y will be y will become 0. Or if it is, that is a different issue. So you have the equation x is equal to 0, y is equal to 0, or x is equals to a or y is equals to b. So वो क्या है? They are line parallel to x-axis and y-axis. So there, it's a different thing. And in fact, there also you'll find out the slope to be 0. So automatically if the slope is 0, m into 0 will be what? 0. So x becomes 0, right? So there also we know that it is going to be that way. But so it is not to get confused any further. I'm not saying anything further because I don't want to confuse you. But the main thing is that you are going to have everything as y is equals to mx plus c, right? So if the slope is given to you and c is y-intercept, then you use this one. If a point and a slope is given to you, you use this formula. If the 2 points are given to you, then you use this formula, right? There is also one more formula which is very rarely used, is when you are given the x-intercept as well as the y-intercept. So if it is given to me that the fourth method is x-intercept and y-intercept method. So if anything, if I am given both x-intercept and y-intercept, and if I consider, so we'll say let x-intercept is equals to a and y-intercept is equals to b, then the formula is x upon a plus y upon b is equals to 1. Direct. We can get the equation of the line as x upon a plus y upon b is equals to 1. Okay. So if I know the x-intercept, if I know the y-intercept, I need not find out the slope, I need not do anything at all. I can just directly use this formula, x upon a plus y upon b is equals to 1. So this is also one method, alternative method of finding out the slope, finding out the equation of the line. Okay, so that is one part. Now we also see something which is called as equally inclined lines. Okay, the next thing what we are seeing is lines which are equally inclined to the axis. So this is because many times you'll be given a question that a line is such that it is equally inclined to the x-axis or equally inclined to the y-axis. So if that is the condition, then you know that it will be, so equally inclined means the line makes equal angles with both the axes. So when is it possible? So suppose if this is the line, or this is the x-axis or y-axis, when can it be equally inclined? When it is passing like this and the angle over here and angle over here is the same. Okay, equally inclined would be that inclination of AB, or we can also have, inclination of AB and CD. We have over here, one is this line. One second, made it wrong. So equally inclined, so the given, if two lines are equally inclined, lines A and B, that means if this is x and y, if one line is coming here like this at 45 degrees and another here is like this, again it is 45 degrees, right? So in this case, the AB inclination is 45 degrees and C. So if this is AB and this is CD, then AB is inclined at 45 degrees and CD is also inclined at 45 degrees. Only thing is that this is minus 45 over here. So in this case, the one part will be tan theta will be 1 and another part will be tan theta will be minus 1. So this is normally required only in case of certain things like you have to find the equation of a line which is passing through a particular point and are equally inclined to the coordinate axis if it is given like that. So if it is like this, that this is the x-axis and y-axis and you got a point over here, and from here there are two lines, one like this and one like this, and they are equally inclined, means this angle 45 and this also is 45 degrees. Right, if such is the condition, then you know that this angle over here will be minus 45 and this will be plus 45. So slope of this line will be minus 1 and slope of this line will be 1. So we already know that this will be 90 degrees because product will be -1. So in such a case, you will just take the m to be as 1 and -1, and so one line will be perpendicular to the other line. So we can easily find out the slope of such lines, right? I don't think I'll start the exercise now because there's no point starting the exercise for just 5 minutes. Instead, I'll make it a different kind of a video, but I'll just explain you one more thing, and that is the equations of, I was just talking about equations of line where x is equal to something and y is equal to something. So let's see those lines. So if I take over here like this is the x-axis and this is the y-axis, and if, what is the equation of this line, this particular line, equation of this particular line, if you see, this is x is equals to 0, okay, and this line y-axis is, sorry, this is y is equals to 0, and here this line is x is equals to 0. So we see that equation of, we had done this thing earlier also, but so it is the equation of x-axis is y is equals to 0, y-axis is x is equals to 0. You can easily find out these values also. Let's take this line. So in this line, what is the slope? The slope over here, tan theta. So we see over here, x-axis, slope is equals to tan 0 is equals to 0. What is the y-intercept? C is equals to 0, but it is touching over here itself. Therefore, y is equals to mx plus c mein m is 0 into x plus 0, so that's 0. So y is equal to 0. That's how you get x-axis. Similarly, for y-axis, what is the slope? Slope is equals to tan 90, which is 1 upon 0. Because it is not defined. What is not defined? 1 upon 0, right? So therefore, over here and C over here, what is the y-intercept C over here? We can't even see anything, it's 0 again. So that's why y is equals to mx plus c. So therefore, y is equals to 1 upon 0 x plus 0. So 0 comes over here, it will become 0y. So 0 is equals to x. So x is equals to 0. In this case now, in both these cases, suppose I tell you that this line is now going to be over here passing through point 3. That means in this case the y-intercept becomes 3. So C is equals to 3. So my value will be y is equals to 3. Why? Because x is already 0. So a line parallel to, so therefore what it gives me? That line parallel to x-axis is y is equals to b. This is b, right? Same way over here. Suppose the line is passing through this particular point. So over here, let's take this as 3. So now the C, it is x, this y-intercept over here, right? So it is, now, okay, in this case we cannot find out because this is 0 and C is not there, it is not touching at all. So anyway, there we'll have to put it as x is equals to -3, x is equals to 3 because it is passing through this particular point. So we'll not confuse ourselves with this part. Yeah, x, it will be given as line parallel to y-axis will be x is equals to a. Okay, because there is no y-intercept as such, but so here the y-intercept will be not 0, but it will be now not touching at all, infinity will be there, and then you need to see this thing. So it will be x is equal to 3 is the final answer, right? So this was one part. You can just remember it this way, forget this calculations. You can just remember this 3 things, that x-axis is y is equal to 0, y-axis is x is equal to 0, and line parallel to x-axis is y is equal to b, and line parallel to x-axis is x is equal to a. This is what you need to remember rather than going through all this kind of hassle, right? So yeah, we will stop this video and we will continue with the exercise 14C in the next video. And then there is no explanation for the 14D exercise. So we will continue with 14D later on. So that will be the next videos.